Okay, crew, here is what we're going to do. We are going to look at the next math problem. And some folks see this problem and they say it is too easy. There are other folks who just can't see it and don't want to be outdone by some middle school kid, and they find themselves hunched over the dining room table at 2 a.m. filled with rage and coffee and racing against their own mortality until they finally see the solution. So let's look at the problem. We've got two circles and a tangent line between those two circles, and we've got two radius lines that go toward the center of the circles, and the question is, what is the distance between the two centers of the circles? So for starters, I actually feel like this might be easier if we rotate it. So let's do that. I actually had a bit of a hint to start this because Nina's class was doing Pythagorean theorem stuff when this problem was introduced. That means it is time for
Geek of the Week.
Pythagoras was born in 500 BC and he started a math church because what makes church service more fun? Math. Pythagoras might not actually have come up with the Pythagorean theorem, much like Thomas Crapper did not invent the toilet, but the two of them did have a love child who they named the Earl of Sandwich. All right, Ted, you can do this. Okay, focus. Two circles. And we want to know the distance between the center of these two circles. All right, let's say that the problem arrived on our doorstep with a 1 there. That is the height of that right triangle. And a 2 over here. And a 4 here. Let's pretend that's the way the problem arrived. Now there's the quick way and the slow way to do it. I was slow to see the quick way. But let's do some geometry on this thing first. We know in geometry, it's almost always the same. It's like if you know one thing, then that means you know another thing. So let us look at the things we know. We see that this radius line on circle 2, that guy, he's perpendicular, because that's a 90-degree angle right there. He's perpendicular to this line. And this guy, this radius line, is also perpendicular to this line. So that means that this line, this radial line and this radial line, these are parallel. So if we were to extend these lines forever, they would maintain the same distance apart. They are as parallel as the L's in parallel. Look at that. They'll always be the same. Now, we know another thing. We know that we've been doing Pythagorean theorem, and the Pythagorean theorem says the following. A squared plus b squared equals c squared. And what that means is if you have a right triangle, and I put that right triangle right there, this is A, this side is B, and this side is C. So if I know A and B, and I square them, I can get the squared value of C, which I can then unsquare by square rooting it. And then I have the hypotenuse, and the hypotenuse is the center, the distance between the center of the two circles. Look at it. It's right there. So what if I knew, oh my God, what if I knew this? What if I drew a big triangle like that? Then it'd be easy. It'd just be the Pythagorean theorem on a single triangle. And I know that this base of this big triangle, that is like this. This big guy. This big guy, I know the base is 4 because these lines are parallel and therefore they're always the same apart, same distance apart. So this guy to this guy is the same as this guy to this guy, so it's 4. Now I know another thing. Because this is 90 degrees, like not only these vertical lines parallel, these lines are also parallel. So they maintain the same distance apart. Over on this side, they are 2 apart. So over here, they are 2 apart. So now I know this big guy. I know the side of essentially side B. If we said this was side A, this is side B, and this is 1 plus 2. And according to my calculations, Alexa, what is 1 plus 2?
1 plus 2 is 3.
3 is the answer. So now I know a squared, which is 4 squared. So that's 4 squared plus b, which is 3, so we'll square that, and that's going to equal c squared. Now, some of you might remember there's this thing that's a 3, 4, 5 triangle. Whenever you have a 3 here and a 4 here, you can just kind of memorize. Look, that's always a 5. That's a special super triangle. But let's say you didn't remember that. That's fine. We'll say 16 plus 9 equals c squared. And then we will say 25. Oh, I forgot to ask. Alexa, what is 16 plus 9?
16 plus 9 is 25.
Yeah, it's 25. Good job, Ted. Then that's c squared, so let's do square root of both sides so we can get down to our c. Square root of 25 equals c, and therefore 5 equals c, and that is our final answer, that the distance between the center of those two circles is 5, because we spotted this, moving this line down as making a big triangle. But if you didn't see that, which maybe you didn't, you could do it another way, which is more involved. So if you don't want to see the other way, you can stop the video now. Okay. If you didn't have that insight that we had before, where you could make one big triangle, let's put the things that we know again. We said that was a 1, this was a 2, and this is a 4. Now, I know this thing from geometry because somebody told me this once, that if you have a line and another line crosses it, these opposite angles are always the same. So if that's angle alpha, that's angle alpha. This is angle theta, then this one's angle theta. They're always the same. The one opposite you, if these lines are straight, they're always the same. So I know that this angle is equal to this angle. And I also know that these two angles are the same. This is a 90 degree right there, and that's a 90 degree right there. I also know that triangles, right triangles, they, well, this is kind of dumb. I know that triangles have 180 degrees in them. So if two of the angles are the same, the third one is the same. So, boom. We'll say that this is angle theta and that's angle theta. So these two triangles are what you call similar triangles. And what that means is that they have all the same angles. And so one of them is really just a scaled up version of the other one, or the other one's a scaled down version of the other one. So let's put some labels on here. This side that goes from theta to the 90 degrees, let's say that is side, I'm going to say that's side B. If that's side B, then we'll put this, its big sister is right there, big B. This hypotenuse is C, and we'll make the big hypotenuse a big C. And let's also say that this is A, right? That's the missing side. So that means that this is a big A right there. And you know what I'm going to do? I'm going to move this 4 out of the way. I don't like where that 4 is. It's confusing me. Arrgh. Get out of there, 4. I put it up here. Hold on to that. It's like 4, and I might put a little marker there. 4 goes from here to here. Okay. So, if I could figure out little c right there, I'd have the whole thing. I'd be home free, because I know that big C equals 2 times little c, because that whole similar triangles. The reason I know that is because right here I can see that little b is a 1 and big B is a 2. So really big B is 2 times little b. And that, I might as well write it down since I've come this far. Big A equals 2 times little a. Now, here's what I wish I knew. I know B, if I knew A, I could do this. Well, I know something. You know what I know? I know that big A plus little a equals 4. Because look, it's got to go up to there. See, that's 4. From here to here, that's 4. And from here to here is A plus little a plus big A. Now, I can do a substitution. I could say, replace that 2 A. Sorry, I can replace the big A with a 2A plus A equals 4. According to my calculations, that means I have 3 A's over here. And then I'm going to algebra this chumpy chump. And I'll say A equals 4 over 3. Haha. Now I can figure out C because I know A and B on this little guy. I can figure out little c. Let's go figure out little c over here. Okay. We'll say equals little c squared. So let's do b squared. Well, yeah. Okay, we'll do b squared then a squared. B squared is 1 squared. And a squared equals 4/3 squared. And that's going to be 1. 1 squared is 1 plus 16/9. When you square a fraction, you square both the top and the bottom. That's going to equal c squared. And then I'm going to turn this guy into, you know what I'm going to do? Shh, watch this. I'm going to turn this guy into 9/9. 9/9 is the same as 1. And I got to do a common denominator. So that's going to be 25. Oh, I forgot to ask. Alexa, what's 9 plus 16? 25 over 9.
9 plus 16 is 25.
Equals c squared. And let's get a square root of both sides. Boom. Square root of 25 over 9 is going to give me my actual c. I can't work with the c squared. I need to know what the actual c is right there. Okay, so when I do a square root of a fraction, I actually do the square root of the top and the square root of the bottom. And that gives me 5/3 equals little c. Now, the distance between the center point here and the center point here is big C plus little c, because it's from here to here, whoops, here to here, and here to here. Okay, I could do that. I could say big C plus little c equals this big old D, which is, we'll say D is the distance between the two circle centers. D. Boy, is that getting messy. Okay. C is, big C is 2 little c's. So I'm just going to plug that in right away. Ready? 2 times 5 over 3 plus 5 over 3 equals the big distance we are in search of. And that is 10/3 plus 5/3 equals D. Oh my goodness, I'm close. 15/3 equals D. Alexa, 15 divided by 3.
15 divided by 3 is 5.
15 divided by 3 equals 5. And that's what we got last time. Big D, the distance between the two circles, centers, is 5. We are geniuses.